Welcome to the Deep Dive, where we flip through the pages of classic computer magazines and revisit the tech that shaped a generation. From beige boxes and basic listings to bold predictions of the future, we'll explore what computing looked like back then and how far we've truly come.
That's right.
Our mission today is to crack open the Personal Computer World Review from January 1985, focusing on a machine that perfectly illustrates the moment the personal computer world decided, once and for all, that compatibility was king. The Sanyo 552.
Ah, the Sanyo. Yeah, this deep dive isn't just about reviewing an old piece of hardware. It's really a critical case study in the chaos of standardization back then.
Right.
When we land in early 1985, IBM's PC has certainly set the standard, no doubt about it. But the market is still this wild, fragmented place. You've got hardware manufacturers desperately trying to undercut IBM's price while offering a machine that is just compatible enough, you know.
Just enough, hoping it sticks.
Exactly. And the Sanyo 552 represents this final, almost tragic attempt by a major player to stake a claim in the professional business sector without paying the full price for admission to the IBM club.
Okay, let's unpack this. The original Sanyo 550 series had already made waves, hadn't it?
Oh, yeah.
It was the machine you bought if you valued sheer financial leverage. We're talking about a system that was bundled with the entire MicroPro software, suite WordStar, CalcStar,
Database tools.
everything, the whole lot.
A software package whose retail price alone often exceeded the cost of the entire Sanyo machine. It was an incredible proposition, really.
It was on paper.
But it failed because, despite running MS-DOS and the 88.8 CPU, it couldn't run off-the-shelf IBM software. That was the killer.
Precisely. That lack of full compatibility was the fatal flaw of the predecessor. So the 552 was introduced as the redemption story, you could say.
The fix. Yeah, an upgraded business micro specifically engineered to overcome that deficit. They improved the disk drives, they updated the DOS, but as the reviewer, Bob Piper, discovered, it still missed the mark on delivering that seamless IBM experience. It's the poster child for almost compatibility, and in 1985, business computing almost was basically a death sentence.
And the stakes were higher this time, right? Because the original Sanyo 550 had been ridiculously cheap.
Cheap, yeah.
The 552 was significantly more expensive. The single-drive version jumped to 999 pounds.
999. Big jump.
And the dual-drive 555-2 was 1,390 pounds. Critically, that's without the monitor.
Right, you had to add that on.
Which could push the total cost closer to 2,000 pounds if you opted for color.
Easily.
So the central question for the reviewer was, did the updated components finally deliver enough compatibility and performance to justify this much higher price tag?
That's the core tension we need to explore. We are looking at a machine trapped at a crucial inflection point in technological history. Really fascinating.
Let's dive straight into section 1 then. The fragmentation trap, the challenge of almost compatibility. This is where the technical details really start to bite.
Okay, so the initial Sanyo 550 series failed to achieve high sales despite its value proposition due to two critical issues. First, there was that natural suspicion, the buying public's ingrained feeling that if a deal seems too good to be true, it probably is.
You get what you pay for, that old adage.
Exactly. But the second issue, the technical one, was far more damaging. The inability to run the growing essential library of IBM software, despite being an MS-DOS machine, that just killed it for serious business use.
So the Sanyo team went back to the drawing board for the 552 to address this original sin. They tackled the most obvious physical difference first, disk formats.
Right.
The original had 160K disk drives. The new 552 moved to 360K double-sided drives, matching the exact format of the standard IBM PC.
Check. That's one box ticked.
They also upgraded the operating system from an earlier version to MS-DOS 2.11. This should have been the key to the compatibility lock, shouldn't it?
It should have been. It was necessary, yes, but not sufficient. And that's the brutal lesson of the mid-'80s compatibility wars.
Oh.
The review repeatedly calls the Sanyo 552 a technically competent machine that can't quite join the club. The hurdles weren't the OS or the processor type necessarily. They were these subtle, insidious deviations in the hardware implementation.
Okay, let's start with memory, because this is where Sanyo's cost-cutting truly crippled the machine's potential, wasn't it?
Absolutely crippled it. The 552 shipped with just 128K of RAM.
128K standard, wow.
Yeah, And expandable only up to 256K using Sanyo supplied chips, which you had to buy and install yourself.
Why was that 256K ceiling so devastating in 1985? What couldn't you run?
Well, it was devastating because 256K was rapidly becoming the de facto minimum requirement for the power applications that were driving business adoption of the PC. Think Lotus 123.
The killer app spreadsheet.
Exactly. Or advanced database management systems like DBase. These packages were optimized for the IBM environment, and by 1985, they demanded 256K, often more. Being limited to 256K and shipping with only 128K immediately locked the Sanyo out of the most compelling professional software library available. It was a massive own goal.
And there's a crucial technical detail buried in that memory specification. The Sanyo used non-parity checking RAM. Can you break down why that was a significant sign of corner cutting, especially for a machine pitched as professional?
Right. Parity checking is a small but vital feature. Basically, the computer dedicates an extra bit for every byte of memory just to check for errors. If a single memory cell flips due to heat or electrical noise, which is pretty common back then,
Yeah, I remember those RAM errors.
the system knows, throws an error, and hopefully prevents corrupted data or crashes. Non-parity checking RAM, which the Sanyo used, is cheaper, but it means the machine has no way to internally detect those memory errors.
So data could just get corrupted silently.
Potentially, yes. For a business machine where data integrity is paramount, this was just an unacceptable compromise. It signaled to the experienced buyer that Sanyo was saving pennies in places that risked pounds of valuable corporate data.
Okay, so the low memory ceiling already restricts the software options, and the quality of the memory itself screams budget build. But the compatibility crisis goes deeper than just RAM, doesn't it? It involves the fundamental way MS-DOS applications talk to the hardware.
It absolutely does. This is the heart of the almost compatibility problem. While the Sanyo ran MS-DOS 2.11 and used the Intel 8088 CPU, the same processor as the IBM PC.
On paper, it sounds right.
On paper, yes, but the vast majority of early performance-critical IBM applications bypassed MS-DOS almost entirely.
Wait, they bypassed the operating system. Why would they do that? That sounds risky.
Speed. Pure and simple. The DOS kernel itself was relatively slow, especially for things like graphics or screen updates. To get the performance they needed, developers often wrote code that talked directly to the specific hardware addresses, and crucially, the system software stored in the IBM PC's read-only memory, the BIOS.
Ah, the BIOS.
If Sanyo's BIOS didn't perfectly emulate every single one of those specific IBM system calls, the software would just fall over. It would freeze, crash, or simply refuse to load.
So it wasn't enough to run MS-DOS. You had to perfectly mimic the underlying IBM hardware and firmware quirks.
Exactly. The Sanyo failed because its BIOS did not offer that perfect 100% emulation needed for the true killer apps. It was trapped in its own proprietary ecosystem, even though it looked like an IBM clone on the surface.
That puts the keyboard deviations into a totally different light then. It wasn't just an aesthetic preference or a minor annoyance.
No, not at all.
The difference meant that the specific keystrokes the software was expecting, keys that directly access the BIOS or specific hardware interrupts, weren't being registered correctly.
Precisely. The Sanyo had a unique, distinct keyboard layout. When you ran a genuine IBM program, crucial function keys or control combinations just didn't function as intended. Sanyo's attempt to fix this was, well, it was kind of a sticking plaster solution.
What did they do?
They included a conversion chart, a physical sheet of paper showing if the IBM program says press F1, you need to press this specific Sanyo key combination instead.
Oh, wow. The reviewer's reaction to that chart really drove the point home, describing trying to learn a new, complex business application while juggling this conversion guide as an impossible feat.
I mean, can you imagine?
I can picture the business owner trying to master WordStar while frantically scanning a laminated guide just to save a document or access the help menu. It's a guaranteed path to immediate frustration and ultimately just rejecting the machine.
Absolutely. And let's not forget the CPU speed here, which ties back into cost-cutting again. The Intel 8088 was clocked at a remarkably slow 3.6 megahertz.
3.6 megahertz.
Yeah. While this might seem like a minor reduction, let's contextualize it. The original IBM PC ran at 4.77 megahertz.
Okay, so noticeably slower already.
And furthermore, Sanyo chose the 8088 chip over the potentially faster 8086 chip.
Ah, the difference between the 8088 and 8086. It's easy to gloss over the numbers, but this is another key cost-saving measure that killed performance, isn't it?
It really is. The 8088 was 16-bit internally, meaning it could process data in 16-bit chunks, which was good, but it only used a slower, cheaper 8-bit external bus to communicate with the rest of the system, memory, peripherals, everything.
So it had a bottleneck built in.
The significant one. The 8086, which many faster competitors were using, maintained the 16-bit internal architecture and used a full 16-bit external bus. Much faster data transfer.
And Sanyo not only used the slower 8088.
They used the slower 8088 and then clocked it slower than the competition at 3.6 MHz to save money on the motherboard design and components. By 1985, competitors were already pushing towards 8 MHz with the full 8086.
Wow.
The Sanyo was operating at less than half that potential speed, guaranteeing a sluggish, frustrating experience, especially with demanding software.
So if we step back, the compromises Sanyo made to save money on the CPU speed, the memory quality, the BIOS compatibility, these were sort of intellectual flaws that trapped the machine in its own micro niche.
They were fundamental design choices with huge consequences.
But let's transition now to Section 2, hardware aesthetics and cost-cutting compromises. When the reviewer actually sat down to use the machine day to day, did those same cost-cutting decisions lead to physical flaws that made the user experience just miserable?
Oh, absolutely. The machine was aesthetically unique, described as an angular 3-box configuration. You had the main processor unit as a low-profile base, and the monitor, which was kind of cube-shaped, sat on top.
Sort of minimalist for the time.
Yeah, and it had a finish typical of Japanese manufacturing then that looked more like a hi-fi system than a business micro. It was superficially quite attractive, actually.
But the looks definitely concealed some serious durability concerns, according to the review.
Yes, the construction was a good example of deceptive aesthetics. It used thin sheet steel. Well, it led the reviewer to suspect it might not withstand the rigors of a busy office or being moved around a lot. It was compact, which was a plus about 15 by 14 inches. But inside and out, the evidence of cost-cutting became rapidly apparent, starting with the least glamorous part of any computer, the power cable.
Oh, the infamous short mains lead. I remember reading about this.
It's genuinely inexcusable. We're talking about a professional machine costing well over £1,000.
A serious investment.
Yet it's shipped with an amazingly short, fixed mains lead, less than 5 feet in length. Just think about that reality in an office setup. Most desks need to be positioned far enough from the wall to accommodate cabling movement.
Right, you need some slack. A fixed cable that short is essentially guaranteeing that every single business installing this machine had to immediately engage in what the reviewer called very undesirable practice.
Splicing cables, yeah.
Splicing on extensions or using flimsy, potentially dangerous connectors just to reach the wall socket. That's truly negligence in design for a product aimed at the professional market.
It was utterly indefensible penny pinching. The reviewer was precise in his criticism, saying this is understandable on, like, a 15-pound poster.
Right.
But inexcusable on a professional machine which costs in excess of £1,000. The moment you force your customers to potentially compromise electrical safety just to plug your computer in, you've really lost the plot.
Completely.
Yeah.
Were there other quirks in the primary components, like the disk drives? They put in the 360K ones. Were they okay?
The drives themselves, the mechanism seemed robust, and the 90-degree rotation locking lever was described as robust and pleasant to use. So mechanically, they were decent.
Okay.
But again, Sanyo managed to introduce a bizarre usability flaw with the status indicator light. The read-write light was described as most unhelpful.
Unhelpful? How?
Instead of illuminating only when the drive was actively being accessed, the critical time not to remove the disk,
Yeah, the don't touch light.
it remained illuminated the entire time a disk was physically present in the drive.
Wait, so the light was just always on if there was a disk in there?
Always on as long as a disk was seated. This completely defeats the purpose of the indicator, which is safety and communication.
Right. You look at the light to know if it's safe to eject.
Exactly. A user could easily mistakenly believe the machine was constantly active, or worse, think it was safe to remove a disk mid-save, leading to data loss. It was a classic example of designing a component for maybe maximum cost efficiency rather than maximum user communication and safety. Just baffling.
Let's look at connectivity. Since they were pinching pennies on the power cord, I assume they skimped on the ports as well.
You assume correctly. To keep that entry price below the psychological £1,000 mark, interfaces were minimal. You got a Centronics parallel port for a dot matrix printer as standard.
Okay, essential for printing invoices and reports.
Absolutely necessary for output back then. But if you needed to connect a modem for dial-up comms, or maybe a serial printer or plotter, pretty essential for business communication.
Yeah, modems were becoming key.
You had to shell out an extra 50 pounds for the optional RS-232C serial board.
50 quid extra for a basic serial port.
Okay.
And even after paying extra for that optional board, the user was still faced with recurring headaches every single time the machine booted up.
Yes. This is another incredibly clumsy implementation. The serial port's default baud rate was set at 1200 BPs.
Which was common, but maybe not what your device needed.
Right. If your modem or printer required a different rate, say 300 or 2400 BPs, you could change it. But those parameters could not be permanently saved in the hardware or system settings.
Not saved. So what happened when you rebooted?
Every time you powered the machine on or performed a hard reset, it defaulted back to 1200 BPs. The user was forced to manually run a simple assembly language or basic program. They actually provided listings just to reset the port parameters every single time.
Oh my goodness. So the morning ritual for a Sanyo owner wasn't just booting the machine, it was booting the machine, then finding and running a specific utility program just to make sure their modem could talk at the right speed before they could even dial up.
It was an ongoing, irritating task. This points to the absence of something like the standard DOS utility, the mode command, which was usually used to program and store these port settings more permanently.
Right. Mode copium 1.9670 N81.
Exactly, that kind of thing. The lack of permanent, flexible configuration made the Sanyo highly unsuitable for anyone needing consistent communication. It really highlights that the machine was truly designed first and foremost for the bundled WordStar CalcStar environment and very little else outside that box.
Now let's talk about the primary interface to all that professional software, the keyboard. This is where the shoestring price truly started to cause, well, physical pain, according to the review.
Yeah, the keyboard was an 84-key unit. The overall feel was described as a little on the light side.
Light, as in easy to press.
Too easy, apparently. Due to the key action and the way the keys reached their hard end stops with little resistance, the reviewer noted that rapid typists could quickly develop tender fingertips.
Tender fingertips. That's not just a usability flaw, that's bordering on an ergonomic hazard. The reviewer actually suggested fitting stiffer springs.
Yes, explicitly. Stiffer or dual-rate return springs were recommended to alleviate the physical discomfort. It's hard to imagine selling a business machine today where the first recommended upgrade for the owner is to disassemble the main input device and replace the internal components just to make it tolerable for heavy use.
That's incredible. And on top of the physical pain, the layout was apparently a minefield of usability flaws. That combined numeric and cursor keypad sounds especially problematic.
It was a huge issue, particularly for anyone doing data entry, like in CalcStar. The numeric keypad doubled as the cursor control cluster, toggled by the NUM lock key. Standard practice for many keyboards then. But Sanyo omitted the necessary LED indicator to show the user which mode numbers or cursors they were currently in.
No light for NUM lock. Oh, that is an irritating omission. Because if you think you are typing numbers into your spreadsheet, but you're actually in cursor mode,
you might accidentally move the cursor way across a complex sheet and enter a number in completely the wrong cell without realizing it until much, much later. Disaster waiting to happen.
it just invites subtle, persistent data entry errors, especially in a fast-paced environment.
Wow.
And the placement of the cursor keys themselves was illogical.
Simply illogical, defying the emerging industry convention. The down arrow key was placed on the 5 key of the numeric pad.
On the 5, not the 2.
Not the 2, which was becoming the standard. It's a small detail, maybe, but in the rapid-fire world of spreadsheet navigation, that unnatural movement would severely slow down and confuse the user. Muscle memory goes out the window.
And finally, for anyone who could actually type quickly enough on this machine to induce tender fingertips, the machine was still designed to slow them down thanks to the operating system's buffering limitations.
Right, the type-ahead buffer was microscopic, a tiny 7 characters. 7 characters. For a skilled typist, this meant that whenever the machine paused for thought like accessing the disk, redrawing the screen, or calculating a function, they had to physically stop typing and wait. If they typed more than 7 characters ahead while the machine was busy, those characters would simply be lost, vanished.
That constantly interrupts the workflow. You could never achieve a smooth, uninterrupted working rhythm.
Never. All these tiny, frustrating decisions just piled up. The short cord, the misleading disk light, the painful keyboard, the illogical layout, the constant need to manually configure the serial port, the tiny buffer. It really defined the taxing, low-tolerance user experience of a cost-optimized 1985 Micro. You had to want to use it.
That's a comprehensive catalog of misery, it has to be said. Let's try and find the silver lining. Let's move to Section 3. The bundled software empire and 1980s onboarding, because this is where Sanyo made its initial reputation, and it was the 552's biggest defense against the critics.
It really was the main selling point, no question. For the dual drive 5552, you received the full suite from MicroPro, WordStar, MailMerge, SpellStar, CalcStar, InfoStar, ReportStar, DataStar, and FileSort.
The whole Office suite, basically.
Pretty much everything a small business needed for documentation, calculation, and data management. We can't overstate the value of this bundle in 1985. Obtaining licenses for all these professional tools separately would have cost an absolute fortune, potentially doubling the price of a standard IBM PC clone.
Let's break down that suite for listeners who didn't live through the 80s WordStar era. WordStar was the standard word processor then, wasn't it?
It was dominant. The equivalent of today's Microsoft Word, perhaps, but infamous for requiring memorization of the WordStar diamond of Krill key commands for navigation and editing. No mouse, remember?
Oh, yeah. Ctrl-E, Ctrl-X,
Nice.
Ctrl-S, Ctrl-S, Ctrl...
Yeah. Exactly. Professional documents, publishing, even internal corporate communications often revolved around WordStar files. But for business, the database component was arguably even more vital. InfoStar, DataStar, and ReportStar represented a complete, locally installed database management system.
So, like Access or FileMaker today, but running off floppy disks.
Precisely. Scaled down for a single user on a machine with limited RAM, but capable of managing client lists, inventory, sales reports, mail merges via MailMerge. These were powerful tools. And CalcStar was the spreadsheet, the equivalent of Excel or Lotus 123, necessary for financial planning, budgeting, forecasting.
So getting all of these, the word processing, the mail merger, the spelling checker, the full database suite, and the spreadsheet, all bundled together for that 1,390-pound price, that really was massive value.
Huge value. It was the reason people considered the Sanyo despite its flaws.
But the paradox, as you mentioned, is that these high-value professional packages immediately exposed every single hardware weakness we just discussed.
Absolutely. It was a double-edged sword. The machine's low clock speed 8088 CPU, coupled with the relatively slow floppy disk access, made screen handling sluggish in these complex apps.
Like loading WordStar.
Loading WordStar, for instance, took about 15 seconds. While that sounds instantaneous today, in context, the reviewer noted that was roughly double the load time of a more modern or fully compatible IBM clone at the time.
15 seconds of just waiting. Just to start typing a memo is a long time when you're paying a grand change for the system, plus the monitor.
It adds up over a workday. And CalcStar, the spreadsheet, suffered badly from that flawed keyboard design we talked about.
Right, the combined numeric cursor pad.
Spreadsheets demand rapid data entry and navigation because the cursor control and numeric keypad were combined, and the down arrow was awkwardly placed on the 5 key. Using CalcStar became, in the reviewer's words, very tedious.
Tedious is not what you want when you're inputting columns of figures.
Exactly. Entering large tables of financial data required constant, unnatural hand movements and carried that constant risk of error due to the lack of the NUM lock indicator. The tool itself was powerful, but the hardware made using it an absolute chore.
So the machine gave you the professional tools, but it demanded immense patience and forced the user to become intimately familiar with the hardware's flaws just to be productive.
You had to learn to work around the machine's limitations.
Speaking of steep learning curves, we need to discuss the unique approach Sanyo took to documentation and training in 1985. This was quite something.
It really was. The documentation itself was voluminous. 3 A5-sized, ring-bound reference manuals covering hardware setup, making disk backups crucial back then, and detailed implementation guides for using each of the MicroPro software packages on the Sanyo specifically.
Standard stuff. Lots of paper.
Lots of paper. But the true novelty, which the reviewer found novel and strangely addictive, was the audio training guide.
The cassettes. I love this detail. Tell us about it.
Okay, so this was provided by an external company, Headline Communications. The tutorial included 2 audio cassettes, an instruction booklet, and a demo disc.
So multiple media formats.
Yes. And this setup was designed to take a raw beginner right from square one through the basics of MS-DOS commands, dir, copy, format, etc., then maybe some programming in BASIC, and then into operating the complex MicroPro software suite like WordStar and CalcStar.
So you had to physically queue up a cassette tape on a separate tape deck,
Right.
a piece of non-computer hardware,
Right, your hi-fi or a portable player next to the computer.
and follow along with the audio instructions, presumably pausing and rewinding the tape manually whenever you missed something or needed to try a command.
Exactly that. It's an amazing window into the steep, slow, multi-step learning process required to use business software back then. No online help, no YouTube tutorials.
It really highlights that the concept of onboarding in the 1980s was measured in hours, if not days, of dedicated, focused training using multiple external pieces of media. The user was expected to be a patient apprentice, willing to sit through foundational lessons before ever achieving real productivity.
You had to invest serious time just to get started.
Now let's bring this into 2025 contrast. The shift is just radical. Back then, a small business invested thousands of pounds in a dedicated, locally installed Angular box running software, paid for with a massive upfront capital outlay. Learning required stacks of physical manuals and analog audio tapes.
And today, small businesses operate predominantly on cloud-based tools, often with subscription models, software as a service, or SaaS.
Right. Pay monthly.
Onboarding is often instant, guided by embedded tutorials within the app, interactive web platforms, or you just search YouTube or ask an AI assistant for instant answers. Compatibility is almost always assumed across devices.
The value has completely shifted, hasn't it, from the physical software license and the specialized hardware box.
To the speed, the access, the service component, the continuous updates of the software delivery. It's a totally different model.
We've moved from a world where the user had to adapt heavily to the machine and basically be a part-time technician,
Definitely.
to a world where the software adapts to the user instantly and universally. In 1985, the MicroPro software was the value proposition. The hardware was merely the expensive, often flawed vessel that held those valuable licenses.
Whereas today, the hardware is often a relatively cheap commodity, and the value is in the continuous, seamless service and the data integration.
It's a crucial distinction. The high initial cost of the Sanyo was tolerated, or at least considered, because the barrier to entry for professional software was so high
Yeah.
that Sanyo tried to mitigate that cost.
But sadly, introduced significant technical barriers to entry instead. It solved one problem by creating others.
Let's talk about quantifying those technical barriers now. Section 4. Benchmarks, competition, and modern expectations. We've established the Sanyo was sluggish, but let's use the specific data points from the review to illustrate just how slow that 3.6 MHz 8080 truly felt in practice.
Okay, yeah, that 3.6 megahertz clock speed was the primary limiting factor. We mentioned the 15-second WordStar load time. Beyond that, the reviewer ran 8 standard benchmark tests to quantify performance against its peers.
How did it stack up?
Not well. Look at BM8, which was described as a more complex, computation-heavy operation. That test took the Sanyo a staggering 96.9 seconds.
97 seconds, nearly a minute and 40 seconds for a single benchmark test.
Yeah.
We talk in milliseconds today for similar operations. If a user had to wait that long for a complex spreadsheet recalculation or a database sort operation,
They would be spending significant portions of their workday just waiting for the machine. The performance was simply inadequate for the demanding business user of 1985, especially if they'd ever used a true IBM compatible or something faster.
but despite the Sanyo's price increase over the original, it was still cheaper than the true mainstream clones, right?
Oh, yes. The fully compatible machines, the tanks like the Compact Portable or the ITT Extra, they were significantly pricier. Sanyo was trying to capture that segment of the market that couldn't quite swallow those high prices but desperately needed the professional applications bundled in.
So it was playing in the budget-conscious, almost compatible space. Who are the key competitors it was trying to dislodge or fend off in that tier?
Well, it faced fierce competition even in its own budget-ish tier. The review mentioned 2 specific rivals that were pushing innovation in different ways, making life difficult for Sanyo.
Who were they?
First, there was the ACT Apricot F1. Remember the Apricot? Very stylish machines.
Yes, distinctive design.
At around 1,490 pounds, it was slightly more expensive than the dual-drive Sanyo, but it was faster, had more memory as standard, and importantly, it bundled its own proprietary but highly regarded software suite. The Apricot was innovative, stylish, but locked into its own ecosystem.
So the Apricot chose the proprietary route. whereas Sanyo was trying for MS-DOS compatibility but failing.
Exactly. The Sanyo was trying to be non-proprietary, aiming for that IBM software library, but just wasn't committed enough in the execution to actually achieve it.
And then there's the Advance 86, which tackled the speed issue head-on.
Right. The Advance 86, as the name suggests, used the faster Intel 8086 processor. This made it a considerably snappier machine than the Sanyo, and it also bundled some software. So it competed on speed and value.
But it had its own problems.
Big problems with build quality and aesthetics. It was widely dismissed by reviewers, including this one, as an ugly duckling, with a massive footprint and suspect construction. It looked cheap and felt cheap, even if it was fast.
So the Sanyo was stuck in this really impossible middle ground. It had better construction quality than the cheap but fast Advance 86.
Probably, yeah.
But it was significantly slower and critically less compatible than the pricier but proprietary and arguably slicker Apricot F1.
Exactly. Its niche required near-perfect compatibility at a lower price point, and it failed the crucial compatibility test while not being the absolute cheapest or fastest option either.
It lacked the strategic clarity necessary to win, really. It tried to split the difference between the IBM standard and the budget market and ended up being, well, too slow, arguably still too expensive for its limitations, and fundamentally too incompatible.
A classic case of falling between two stools.
Let's perform our 1985 versus 2025 analogy again. Think about the substantial investment the Sanyo 552 represented back then. £390 for the dual drive system, plus maybe $499 for a decent color monitor. Let's call it nearly £1,900.
A huge sum in 1985 money.
That bought you 128K of non-parity RAM, a sluggish 3.6 MHz 80E80 CPU, and dual 360K floppy drives, all encased in that angular, potentially flimsy steel chassis with a dangerously short power cord.
And today, what does 999 times significantly less in real terms buy you?
Well, it buys you a premium laptop, or a very decent desktop, with a processor clocked in the gigahertz range thousands of times faster. Memory measured in the tens of gigabytes, not kilobytes. Terabytes of incredibly fast SSD storage, not 360 kilobytes on a floppy. And often high resolution, like 4K, graphics capability built in.
The computational difference isn't just linear, it's astronomical. It's almost incomparable. The Sanyo's performance relative to its price point was borderline unacceptable even in 1985 by emerging standards.
And the question the reviewer implicitly posed, was the Sanyo fast enough for a small business then, is amplified a million times today. Could modern users tolerate a machine slower than a current mid-range smartwatch for professional business use?
The answer is just a resounding instant no. Our expectation of speed, of responsiveness, has entirely redefined what professional means in computing terms. Waiting 15 seconds for an app to load is unthinkable.
And imagine if a modern user had to run a program every time they booted up just to set their Wi-Fi parameters, or had to deal with a fixed 3-foot power cord and a keyboard that physically caused tender fingertips.
They would return the machine within an hour, probably less. The value proposition has shifted entirely from merely owning a costly software license bundle to demanding flawless performance, seamless usability, and instant connectivity.
That brings us perfectly to our final section, Section 5. Legacy and the lesson of standards. The Sanyo 552 really feels like the last gasp of an old way of thinking about personal computers for business, doesn't it?
I think that's fair. It was a technically competent machine in many ways, and as the review concludes, a remarkably complete machine at a very attractive price if you only considered the bundled software. But its ultimate fate confirms the brutal lesson of the mid-1980s. Proximity to compatibility is not compatibility. The market became absolutely unforgiving, demanding 100% adherence to the de facto IBM standard to gain access to the widest, deepest pool of application software, the software that businesses actually needed to run.
This machine stands as a monument, almost, to the moment that standardization truly won. It shows that merely having the right processor name, 8088, and the right operating system, MS-DOS, wasn't enough.
Not nearly enough. You needed the right memory sealing, the right keyboard interrupt calls handled correctly, the right BIOS functions implemented perfectly. The ecosystem, driven by software developers targeting IBM, demanded perfection or near enough.
And this reveals so much about the culture of computing at that time and what it demanded from the user.
Oh, it demanded immense, almost superhuman patience. Not just waiting 15 seconds for WordStar to load or that agonizing 96.9 seconds for a benchmark calculation.
But managing that tiny 7-character type-ahead buffer, constantly having to pause your typing to wait for the machine to catch up, That alone would be maddening today.
Absolutely. And you had to have a deep tolerance for poor, sometimes even dangerous usability, the illogical key placement, the misleading disk light, the fixed short power cord, and the sheer absurdity of having to run an assembly program every boot just to set the communication parameters correctly.
The user was constantly expected to compensate for the machine's design flaws and cost-cutting measures.
It was a world where the user had to adapt to the machine, often becoming a sort of system technician by necessity just to keep the business running smoothly. Compare that to today, where we expect demand, really, that the hardware and software adapt seamlessly and instantly to us.
The Sanyo story is a profound reminder of the true cost of fragmentation and the immense value delivered by standardization, even if it felt restrictive at the time.
It really is.
Now, if we connect this to the bigger picture, it raises an important question about the nature of technological progress, doesn't it? Today, we rely on near-universal standards. USB-C, Wi-Fi, common operating systems like Windows, Mac OS, Android, iOS. Everything just works together, more or less predictably.
Generally, yeah. Plug and play mostly.
But back in the 1980s, the chaos, the very fragmentation that ultimately killed machines like the Sanyo fostered incredible diversity. Every company had to try a unique approach, a different angle, to out-IBM because they often couldn't afford to replicate it exactly or wanted to differentiate.
You saw some really weird and wonderful designs back then. Some great ideas, some terrible ones.
And that leads to a fascinating final thought for you, the listener, to take away from this deep dive. We've gained incredible ease of use, speed, and reliability through the standardization that eventually triumphed over machines like the Sanyo 550,002. No doubt about the benefits.
Huge benefits.
But was it the frustration, the tender fingertips, the constant tinkering, and the incompatibility nightmares of the 1980s? Was it somehow worth the raw creative diversity and the sheer number of unique hardware designs and software approaches it fostered? Or is the smooth, predictable, and universally compatible computing ecosystem we have today always the preferable outcome, despite maybe feeling a bit more homogeneous?
It's a great question. Predictability versus chaotic innovation. Something to mull over the next time your phone updates seamlessly over Wi-Fi without you ever having to pull out a cassette tape or run a configuration program.
Indeed. Thanks for listening to The Deep Dive. If you enjoyed this trip through the pages of computing history, follow or subscribe so you don't miss our next deep dive into another classic issue. Until next time, keep your floppies safe, your curiosity sharp, and may your pixels stay perfectly aligned.